This is a short webinar on the Developing Fraction Sentence 3 and 4 workshop. So the question is, why don't students hit a home run in their work with fractions? And the answer is they never get to first base. For example, in this item from a National Assessment of Educational Progress study, only 25% of fourth graders, this is a national sample, were able to indicate which of these fractions is closest to a half. Now notice that they could have eliminated 2 halves because that's 1, and they could have eliminated 1/5 and 1/6 because they're very small. So if nothing else, using elimination, they should have gotten 5/8. And yet, only 1/4 of the students were able to do that, which means that when teachers work with fractions, very often students have no idea what we're talking about. So we would like our students to become experts in working with fractions, but we cannot skip the basics. And much of those basics are covered in the 3rd grade. And we have the full day workshop available, where we go into much more detail than I'm able to go to in this short presentation. So in the first part of the webinar, we're going to be talking about lessons that can be found in the red booklet, Student Workbook A. So if the yellow block is a whole, what fractional part is each of the red blocks? We ask the students to take out their red blocks, place them on top of the yellow. They see that 2 of them fit, and they can tell you that each one is a half. So we then ask the students to explain why the red block is a half, and very often students will respond by saying that there are 2 parts that make up the whole. And so the very first thing that we as educators need to clarify is that that definition is not good enough. For example, as you could see here, we have 2 parts that make up a whole, but neither part is a half. And so the correct language is that if one whole is partitioned or broken up into 2 equal parts, each part is called a half. And we write this symbolically this way. We say if y equals 1, if the yellow block is the whole, the red block is a half. And then you follow the same procedure. You ask them to place the blue blocks on the yellow block. They see that there are 3 of them. The 3 blue blocks are equal, so each one is a third. So if y equals 1, b is a third. And likewise, with the green blocks, as you see, there are 6 of them that form a whole. So if y equals 1, r equals a half, b is a third, and g is a sixth. Now the students learned those names very, very quickly, and you could do a quick test with them. You could lift up the red block. How much is the red? How much is the blue? The red, the green, the blue. But within a minute or two, they understand the value of each block because they have different colors and they have different shapes. And so it's very easy to recognize immediately the value of each one. Students can actually visualize these images. The first concept then the students need to learn is that of a unit fraction. It's 1 part when a whole is partitioned into equal parts. So therefore each red, blue, and green part is a unit fraction. It is 1 part when a whole is partitioned into equal parts. Once the students learn what is a unit fraction, we're ready to talk about the definition of a fraction. So the fraction 3/6 is the quantity formed by having 3 parts of size 1/6 referring to the same whole. Those last few words are crucial because you could have a sixth of the Empire State Building, a sixth of a small house, a sixth of an ant, for example, and that would not be 3/6. It has to be referring to the same whole. So to clarify that, it is very helpful to use the language of copies. 3/6 are 3 copies of 1/6. When you make a copy of something, it's obviously the same size. This language assures that we are speaking about the same whole. So In the student workbook in lesson 4, the students need to name the fractions that are represented there. So if this one is 1, and since the green block, each one is a 6, this one has 5/6, and this one has 4/3. So the students have practiced naming the blocks. Now, in the red booklet, the students work with the concrete fraction blocks with rectangular grids and number line. The rectangular grid is more abstract, and the number line is the most abstract of all. So what fraction of the rectangular region is shaded? The students count the number of small boxes. There are 20 of them, and 4 of them are shaded, so the answer is 4/20. We're not looking for the answer of 1/5 here because students have not been introduced to equivalent fractions yet. Now, what is the length of this red segment? So the red booklet, some of the lessons in the red booklet literally will take 5 or 10 minutes. Others might take 15 or 20 minutes. It's a good idea for the teachers to try to do 2 or 3 lessons a week to include that in their instruction. So this is lesson 8. So I'm skipping some of the lessons. Each lesson in both the red and the blue booklet, just like in hands-on equations, each lesson covers one concept only. So therefore, when I'm doing lesson 8 here, I'm skipping some of the preliminary work. In any case, what is the length of this red segment? So we see that the distance from 0 to 1 is partitioned into 4 equal parts. 1, 2, 3, 4. And therefore, this red segment is going to be 5/4 because it's 5 of those small parts. So the students in lesson 10 are asked to locate these points on a number line. So the students see that between 0 and 1 you have 5 parts. So each of the small segments is a fifth. So this would be 4/5, this would be 5/5, and this would be 9/5. So the students need to know how to name points on the number line. And in the workbook, you'll find examples where 1 and 2 are not given. They need to decide where to place the 1 and where to place the 2. And the answer key is very helpful because it's laid out the same way as the workbook, so the teacher can very quickly check the responses versus the answer key. Okay, so then we get to equivalent fractions, which is a major part of the 3rd grade workbook. 2 fractions are equivalent if they are the same size. So we asked the students to answer this question. 1/2 is equal to how many sixths? So we can help them out if need be. 1/2 we know is a red block. A sixth we know is a green block. So this question really is asking 1 red block is equal to how many green blocks? So the students can lay that out and see that 1/2 is equal to 3/6. Because 1 red block is equal to 3 of the green blocks. And then we get to something like this. 3/2 equals how many 6? Well, they go through the same process. They lay out 3/2, which are 3 red blocks, and they see how many green blocks are needed for equality, and the answer will be 9. So 3/2 is equal to 9/6. Now, what very often happens is that once the student lays out the first red block and the next green block, they don't need to actually spread out all of them. There are various ways they'll do it. They'll say that if 1 red block are 3 green blocks, then 3 red blocks will be 9. And then they'll get 9/6. You'll find that 3 or 4 different ways the students have for obtaining that answer. So the approach we are using is very similar to the approach in hands-on equations. The problem is expressed in symbolic format. We say 3/2 equals how many 6. We then transfer the problem to a problem using fraction blocks. How many green equals the number of red? We solve using the fraction blocks, and then we answer the problem. We provide the symbolic answer. So we'll give you these videos. We'll show you young students applying the methods we are discussing. The students also have to use equivalent fractions using rectangular grids. Now, notice that in all of our work with equivalent fraction in third grade, we're not asking the students to memorize a rule, such as, for example, 4 goes into 8. 2 times 2, that's not our goal here. We're trying to move away from something rote before they have any understanding of what they're doing. Rather, we see here that these two large rectangles are the same size, and we see that the blue portions are equal. This blue portion is 1/4. This one is 2/8. So we see that 1/4 is 2/8. So using this figure, the students are asked to supply the missing numbers. So for example, to figure out how many 8s are 2/4, well, 2/4 are 2 of these long rectangles, and 2 of those rectangles will be 4 8s. Likewise, 3/4 would be 6 8s, and 4/4 would be 8 8s. Okay, so it sounds simple enough, but with the students, you'll need to do a little work with that, but will be able to pick it up. Okay, so fractions equivalent to a whole number, that's also part of the third grade standards. So the most obvious ones are 2/2 are a whole, 3/3 are a whole, and 6/6 is a whole. So we see that when the numerator and denominator are the same, the fraction will be equal to 1. And the students need to compare the size of unit fractions. So the first time we ask them to insert the symbol less than, equal, or greater in here, they'll tend to say 1/3 is less than 1/6 because 6 is larger. Okay, that's how they'll respond before they think about it. Once you ask them to take out the blocks, they'll see that 1/3 is greater than 1/6. And so you can formulate the statement that in comparing unit fractions, the one with the smaller denominator is larger. Or if you prefer, you could say the one with the larger denominator is smaller. And now we can consider the relative size of two fractions with the same numerator. So let's compare 2/3 with 2/6. We ask them to take out the blocks. This is now, we're up less than 30 here. So this would be if you do 2 or 3 lessons a week, you're talking about 2 or 3 months into the program. So the students take out, they see that 1/3 is greater than 6, so therefore 2/3 is greater than 2/6. So if two fractions have the same numerator, the one with the smaller denominator is larger. So this is a summary statement, but this doesn't come into existence until after the students understand it using the blocks. And then you have several enrichment lessons at the back of the red booklet. The recommendation is that you do one of those after each 7 lessons. That becomes a nice motivational device for the students because they enjoy these enrichment lessons. So for example, the first one is considering blocks other than the yellow block as the whole. So if the blue block is the whole, how much is the green block? And they'll have, they'll be able to tell you that this is 1/2. I've worked with kids as young as 6 years of age, and they see that very quickly. So if B equals 1, G is 1/2. Now this one is more difficult, but it's not too bad. If R is equal to 1, how much are 2G? And the answer is going to be 2/3. So that the green block is only 1/6 if we're talking about the yellow block as a whole, but otherwise the green block may have different values depending on the problem. Okay, so the strategies that we have presented then so far deal with the red booklet, Developing Fractions Send Student Workbook A. It has some 30 lessons. So if you do 2 or 3 lessons a week, you're talking about less than 10 weeks to complete it. The lessons are sequential. Some lessons are done very quickly, but you want to go over them in order. There are review exercises that are interspersed so that the students are always recollecting what they did earlier. So we encourage you to try using this program and report back on how the students are doing. The responses we're receiving so far are encouraging. So now let's go on to the student workbook B. So workbook B ideally assumes the students have had the content of workbook A, but in some cases, or many cases, they may not have, that may not be the case. So we attempt to provide a very small introduction as needed in workbook B. But it's helpful if the teacher using workbook B has workbook A so that he or she can strengthen any area that's needed. So we will begin with addition of fractions with the same denominator. So what's the sum of these fractions? So notice we don't begin by giving the students a rule. Rather, we say to them, take out the fraction blocks. Once they do that, you have 3 green blocks plus 2 green blocks. We're assuming the yellow block is 1. So obviously, altogether, you're going to have 5, 6. You're going to have 5 green blocks. And there's no way that these green blocks changed size. Right, so 3, 6 plus 2, 6 will be 5, 6. So this type of common error is avoided. When you see students doing this error, you know they have no idea what they are doing. So you have examples like this in the blue booklet. You have to determine, insert equal or not equal to make the statement true. The first one is true because 4, 6 is here and 4, 6 is here. The second one is not true because 5 halves is not equal to 6 halves. A good portion of the 4th grade standards and the blue booklet has to do with comparing fractions using a benchmark. So students need to know at a glance when fractions are less than 1, equal to 1, or greater than 1. So we notice that 3/3 is a whole, and that the numerator is equal to the denominator. When the numerator is less than the denominator, the fraction is less than 1. When the numerator is greater than the denominator, the fraction is greater than 1. So then the students are asked to compare these two fractions, less, equal to, or greater. So this is about the simplest type of benchmark fractions because notice that 2/3 is less than 1 and 5/4 is greater than 1. So this is the easiest type to compare. So 2/3 is less than 1 since 3/3 equals 1. 5/4 is greater than 1 since 4/4 equal 1. So since 2/3 are less than 1 and 5/4 is greater than 1, we see that 2/3 are less than 5/4. So in lesson 8, the students have examples that they need to figure out of this type. And we can justify it using a visual fraction model. Notice that if this is a whole, this rectangle, 2/3 is much less than 5/4. Okay, so now we get to an example such as this. This is lesson 13. We're comparing the first sum to the second sum. So we've said earlier that 1/3 is bigger than 1/6. Therefore, 1 1/3 will be larger than 1 1/6, because the more that is added to a number, the greater the result. So that's lesson 13, where students have examples of that type. Now, notice that first the students work with the sum of fractions, and they learn that skill, and only later do they combine that into 5/4 and 4/3, right? In the prior lesson, they learned this as 1 1/4 and 1 1/3, but here now they go up a step further. So 5/4 will be less than 4/3. Why? because 5/4 is 1 1/4, and 4/3 is 1 1/3, and a fourth we know is less than a third. So now in lesson 11, we're comparing fractions to a half. And we notice that 3/8 is less than a half because the numerator is less than half of the denominator, and 4/6 is greater than a half because the numerator is greater than half of its denominator. So now the students have a problem like this. This is a little more difficult now, but this is lesson 15. We need to compare 3/7 and 5/9. So the way to help the students, as you see in the video coming up here, is to ask the students, what's half of 7? It's 3 1/2. What's half of, and 3 is less than that. What's half of 9? Is 4 1/2, and 5 is greater than that. So that's the approach that you want the students to gain. So 3/7 is less than 5/9 because 3/7 is less than a half, where 5/9 is greater than a half. Okay, and here you see this young lady using this approach. I think she needs some guidance from the instructor to help her. Now, in the blue booklet, our goal eventually is to have the students be fluent with fractions, right? We want them to be able to do calculations. Arithmetic is, we want arithmetic to be a tool, like hammer and nail, screwdriver for someone who works in that field. We want arithmetic to be a tool. However, we want them to also have some understanding of what they're doing, and it'll be easier to learn. So before we present arithmetical solutions, we want them to experience it concretely. So, for example, here we're adding two mixed fractions. Solve with the fraction blocks. So we ask the students to take out their fraction blocks. One yellow block and two blue blocks added to, okay, so here we go. 1 2/3 plus 1 2/3, and we notice that we can form an additional whole here. So the answer is going to be 3 1/3. But notice something very, very interesting. With the blocks, we're able to form additional wholes, and when we do with arithmetic, we're also going to be forming additional wholes. So that the learning is very exact from the concrete to the pictorial with these blocks. So in lesson 20, they have this practice adding the mixed fraction using the blocks. And then when we do it using arithmetic in lesson 21, we add the whole number components, just like we added the yellow parts, and then we add the fractional parts, and we see that we can form an additional whole here. So the students gain practice doing the computations with the blocks and then doing it on their own, just using arithmetic. Okay, let's look at subtraction of fractions with the same denominator. So we ask the students to take out their fraction blocks, 2 1/3 minus 2/3. The first problem we see is that we don't have two blue blocks to take away. So what can we do? You could see what suggestions students may have, that they'll have suggestions. So one approach is to realize that we can replace the yellow block by 3 blue blocks. So this is 2 1/3, and this is 2 1/3, but now we can take away 2/3, and we have the answer of 1 2/3. So again, when we do this subtraction using arithmetic, one approach that we can use is the same one we've used here, and that is take one of these wholes from the 2 and replace it by 3/3. Then you'll be able to subtract, because then you'll have 1 4/3, and you'll be subtracting 2/3. Okay, we'll send these videos along with the file. Now, we present several methods for subtracting subtracting fractions. So one approach is to convert a mixed fraction. 3 and 2/6 is a mixed fraction into a mixed improper fraction. Okay, so 2 and 8/6 I'm calling a mixed improper fraction because 8/6 is improper. And the way we do that is we take one of the wholes from 3 and convert it into 6/6. So we see that 3 and 2/6 equals 2 and 8/6. And then we use the same approach to find the difference using arithmetic. We'll be taking a whole from the 3 wholes and changing it into 6/6. So it becomes 2 and 8/6 minus 1 and 5/6, and that is 1 and 3/6, or 1 1/2. So this approach to subtraction involves renaming or exchanging a whole for 6/6. We also want the students to be able to subtract using improper fractions. So first, again, we teach that skill using the fraction blocks. Use your fraction blocks to convert the mixed fraction into an improper fraction. Well, 2 1/3 is here, and here you have 7/3. So this is lesson 29. So what I'd like to point out here is this. We don't provide the students with a rule for getting 7/3. Rather, we want the students to use their heads. Since they know there are 3/3 in a whole, they're going to be 6/3 in 2 wholes, and you have 1 more third, and therefore you have 7/3. And you do that instantly, as quickly as you do it using a rule. So find the difference by converting both fractions to improper fractions. So there are 6/6 in a whole. So 18 and 2 would be 26, and this would be 11/6. Okay, and the answer is 1 1/2. So we want students to do that too. Now, as I mentioned in the prior webinar with the other staff members, in our full day workshop, we also discussed finding the difference using addition. Now, we don't have a lesson on addition in the 4th grade workbook, but there will be lessons on addition, on doing subtraction using addition in the 5th grade workbook. So what do we mean finding the difference using addition? So first of all, we know that 3 take away 1 and 5/6 is 1 1/6. We know that because if we add 1 1/6 to 1 and 5/6, we get 3. 1 and 1 is 2, 1/6 and 5/6 is a whole, and so we get 3. So the first thing students need to know is they need to be able to find the answer to a question like this mentally. 3 take away 1 and 5/6 is 1 and 6. Now, once you know that, since we know that 3 take away 1 and 5/6 is 1 1/6, we now can answer the question. 3 and 2/6 is more than what we had before. So if you're subtracting 1 and 5/6, you're going to have the same answer as before, but you're going to have 2/6 more because you started with 2/6 higher on top. And so the answer is, it looks like there's an error here. Okay. There is an error here. Let's see if I can fix this error. 1 and 1/6 plus 2/6. It looks like it should be 1 and 3/6 or 1 1/2. It looks like the answer should be 1 and 3/6, right? 1 and 1/6 and 2/6, 1 and 3/6, 1 1/2. My apologies for that error. Okay. And now we're getting to some of the last topics in the 4th grade standards, multiplication of a fraction by a whole number. Previously, we said that 3/6 are 3 copies of a 6, and we wrote that as 1/6 plus 1/6 plus 1/6. Now the students learn a shortcut notation for that. 3/6 are 3 times a 6. And we say that 3/6 is a multiple of the unit fraction 1/6. And if you want to be more specific, you can say 3/6 is a 3 multiple of 1/6. So let's show that 4 times 2/6 is 8/6. Now, when you and I were in school, we were given a rule for this without any kind of explanation as far as I can recall now. But notice how easy it is to justify this. Here we have 4 sets of 2/6, and we easily see that that's the same as 8 sets of 1/6. So 4 times 2/6 is the same as 8 times 1/6, which by definition is 8/6. And we have a word problem like this. If a train travels 1 2/3 miles per minute, what distance does it travel in 3 minutes? Write an equation to represent the problem. So an equation might be something like this. First, we use a letter to represent the unknown. So let d be the total distance traveled. Then d would be 3 times 1 1/3. And this can be solved using the fraction blocks, and we see that the answer is 5. You can also solve it by multiplying 1 2/3 by 3. 3 times 1 is 3. 3 times 2/3, according to what we just said, would be 6/3 or 2, so the answer would be 5. So this then is a short webinar, a short presentation that discusses the ideas in the Developing Fraction Sense Workbook A and B. It discusses the ideas in the full-day workshop, but of course in a full-day workshop, the participants have a chance to work with these concepts, and we go into additional ideas that we're not able to present here. So I hope that this has been helpful to you. Thank you very much. This is Dr. Henry